Hey guys, this is Notes 4.2 Sunpath, and I'm starting out with first a picture here. And what is happening in this picture is kind of perplexing. All right, you see the sun normally rise in the east, sets in the west. This picture, if you look closely, it looks like it's setting and rising in the same direction. This cannot happen in a normal situation or normal latitude or where we are. Okay, we normally see it rise in the east, set in the west. This is taken in an area where the sun doesn't rise or set sometime a year, which would be towards the North Pole or South Pole. And you can see, so it's going down, it doesn't quite go below the horizon, then comes back up again. So this would continuously do this, and you would have 24 hours of daylight in this picture or this situation. And this can only happen in the polar regions. So we're going to talk about sunpaths today. That's a unique sunpath for the polar regions. Our sunpath will look a little different, but there is a pattern to it throughout the year that you guys have to learn. Okay, so we're going to talk about sunpaths, which again are arcs. And you can see this picture is showing an arc. So it makes an arc in the sky from sunrise to sunset. And it moves at 15 degrees per hour, once again, due to the Earth's rotation. It's at its highest point. We call it solar noon. And again, that can vary between a little bit before or after 12 noon because of, again, the length of the sun path. And also, we have time changes in the mix. So this varies the time by a little bit throughout the year. Also, longer length. Longer day, you guys know that makes sense. And the shorter length equals shorter day. So the noon sun also changes with the season. The lowest angle is going to be during the winter, and that's why it feels colder, because the sun's not as strong. And the highest angle is in summertime. That's why it feels warmer in the summertime. So here's a picture to kind of show you that. So sun in the summertime is much higher in the sky than it is in the winter time. Okay, so here's a little animation to kind of put this together. All right, so we're going to have the sun starting at 6 a.m. here. That's going to be our sunrise time. Remember, this would be in the east direction. It's going to rise up 15 degrees each hour until it reaches noontime, and then it would actually set in the backdrop. I will show you that in the coming pictures. But the type of question they could ask you, they could show you the degrees and then ask you what time it is between two positions. Remember, 15 degrees per each hour. Or they could do the reverse, show you the time and ask you how many degrees between each location. So you have to do the math in the reverse sense. Okay, so important lines of latitude, which again are important for seasonal reasons. Tropic of Cancer, which is 23.5 degrees north, and Tropic of Capricorn, which is 23.5 degrees south. And the equator, of course, and North Pole, which is 90 degrees north, and South Pole, which is 90 degrees south. Why are these important? Well, Tropic of Cancer is where the sun hits directly on the first day of summer for our northern hemisphere. And that's why we have summertime, because the sun is positioned more to hit the northern hemisphere. And then the reverse is true for our winter time. It hits 23.5 degrees south, which is further away from our hemisphere. And therefore, that's why it's winter time. And if you notice the zodiac symbols, Cancer is June, Capricorn is December. Now it makes sense why they named it that. Also, Arctic Circle, 66.5 degrees north, and Antarctic Circle, 66.5 degrees south. That marks where you can have 24 hours of daylight at least one time a year. That and all the way up to the North Pole. And same thing with the Antarctic. So Antarctic Circle down to the South Pole, you can have 24 hours of daylight at least once a year and 24 hours of darkness. Okay, solstices. This brings us to the seasons. You guys heard of summer solstice. That means sunstop solstice. And what that means is the direct rays of the sun the vertical ray, is going to stop moving north or south on the globe when it reaches the solstice. So vertical rays are where the sun's rays strike at 90 degrees or perpendicular to the Earth's surface. The summer solstice marks the first day of summer. In the northern hemisphere, that's June 21st. And the vertical ray is hitting 23.5 degrees north, the Tropic of Cancer. Also, the North Pole is tilted towards the sun. So if you notice in the picture, it has 24 hours of daylight up in the North Pole. And the South Pole is in 24 hours of darkness at that same time. And the reverse, okay, so what is the first day of summer for the southern hemisphere? It's going to be December 21st. So when we have summer, they have winter. And the vertical ray is then going to hit in the southern hemisphere at 23.5 degrees south. Okay, winter solstice is the first day of winter. December 21st, the vertical ray is hitting 23.5 degrees south, the Tropic of Capricorn. And northern hemisphere, December 21st is our date for that. And the North Pole is tilted away from the sun as pictured in the diagram here. So you notice it has 24 hours of darkness up in the North Pole, and the South Pole now has 24 hours of daylight. Okay, and the reverse is true for southern hemisphere. Their winter solstice is June 21st, when the South Pole is tilted away from the sun. That's our summertime. So it's exact opposite the seasons between the northern and southern hemisphere. Equinoxes. The definition of equinox is actually night of equal length from Latin. There's 12 hours daylight, 12 hours darkness all over the earth. The vertical ray is striking at the equator exactly, and we get 12 hours daylight, 12 hours of darkness throughout the whole globe, no matter what on those dates. The season is spring or fall that this happens. And here are the two equinoxes. The dates can vary a little bit. That is due to leap years, and also so we do the leap year correction because our year is actually 365 days, but it takes 365.26 days to revolve around the sun. So they have to correct for that every 4 years for that reason. Go back. The fall autumnal equinox is September 21st on average, the first day of fall in the northern hemisphere. And then spring or vernal equinox, again, on average, the 21st of March, the first day of spring in the northern hemisphere. And again, those dates can vary by a little bit, a day or two. Sunrise direction. This is something you need to memorize. So September 21st, March 21st, the sun is exactly rising on east and west. Those are the only dates where that happens. So due east, due west, we call that. In June, the sun will actually, in its path, shift towards the north a little bit where it rises and sets. So we call it north of due east. For short, you can call it north of east. And then it sets north of west. So we'll talk about that shift a little bit in the diagram in the next slide. December 21st, it shifts towards the south. So it's south of east, south of west for sunrise and sunset. And here it is in the picture. So here's June 21st. So again, it rises north of east, goes up to its highest angle of the year, and then sets north of west. And then spring and fall in the middle will rise and get to a middle angle and then set due west. And then lastly, winter, you notice the smallest sun path. It's rising south of east and goes up to its lowest angle of the year and sets south of west. Now also to notice, these are all parallel to each other, and they vary by exactly 23.5 degrees. So the position along the horizon, it changes by 23.5 degrees. So it's 23.5 degrees from due east up to north of east. And same thing with the noontime sun position. So for New York State or Long Island area, southern part of New York, we get to a maximum of about 73.5 degrees or so. And then it lowers by 23.5 degrees to 50 degrees for March and September. And then another 23.5 degrees downward, our winter sun is at 26.5 degrees above the horizon. All right, and here they are just animated out. So the apparent path through the sky is an arc, as I mentioned. The path varies with the seasons, and the noontime altitude varies with the season by 23.5 degrees, which is the tilt of the Earth, guys. So that's where it comes from. It's no coincidence. Also, because this is New York State, a couple little things to note. So I'm going to start with the summer sun path. So again, north of east rises up to 73.5 degrees approximately. You notice it never reaches zenith in New York State. Zenith can only be reached between 23.5 degrees north and south on the globe. That's the only place where you can get direct sunlight. Also, the noontime sun is in the southern sky. All right, and that's why all the paths you notice, starting in the east, general direction, so this is due east, up to its point in the south sky, and then it sets due west for the spring and fall. And I mentioned this to my students in my class. The north side of your house in the northern hemisphere will actually be dark compared to your south side. And that's why a lot of your houses have been designed the way they are, to face the sun. Certain rooms are positioned in the southern part of your house if it's well designed, like your kitchen maybe, or your dining room. So basically, the sun paths vary with the seasons. They're longer in the summertime than they are the winter. You can clearly see it on the diagram. And remember, the sun is in the south sky in New York State for the noontime. All right, also they'll ask you in some questions about shadows. We know that the angle of the sun is greater during the summertime and least during the winter time. So as a result, the shadow of a person or observer will be longer in the winter because the sun is lower in the sky. And the reverse will be true for summertime. It's higher in the sky, so you're going to have a shorter shadow. And same thing with daytime. You can actually do the same thing. The shadow is going to be shortest when the sun is at the highest angle, so solar noontime. And longest when the sun is lower in the sky near sunrise or sunset. That's why you see more shadows that time of day. But be aware, it's not directly on sunrise or sunset that you're going to have the shadows, because the sun would be set by that time or not up yet. So therefore, it has to be just above the horizon by a little bit to see those long shadows. And lastly, what about spring and fall? Well, they kind of fall in between, so therefore they are average size shadows. So they would be exactly in the middle between the winter and summer shadows. And I'm just going to leave you with this picture. This is actually a picture, I think, from the Pacific somewhere. And this is an area where they have a midnight sun, so a sun that never sets. So kind of an interesting picture. The sun would actually just stay in the sky and it would rise and never quite set. And that's it for today, guys, and I thank you for tuning in.